In these notes, we're going to continue our work with graphing systems, but 3.5b notes will be graphing systems of inequalities, not equations. So remember, a linear inequality is where we graph a line and then shade one side or the other to represent all the possible solutions of that inequality. And so when you have a system of inequalities, which again is two or more linear inequalities, the goal here is not to find the point where these lines intersect, but to find where the two linear inequalities, the two shaded regions, overlap. Okay, so the solution here to a system of inequalities is a set of all points that make both inequalities true. So where a system of equations has one solution typically, a system of inequalities will have infinite solutions based on the shaded region that is overlapping. So let's really quickly review the rules for types of line and shading for linear inequalities. So when you have one of these symbols, you're going to use a dotted line. When your inequality symbols have the equal to bar at the bottom, you're going to use a solid line. If your linear inequality in slope-intercept form starts with y is less than or equal to, you're going to shade down. And if it starts with y is greater than or equal to, you're going to shade up above the line. Also, don't forget, if you multiply or divide by a negative, when you're solving the inequality, you need to flip the symbol. Okay, so don't forget all these rules for inequalities. They all still apply. Okay, so let's practice one. So first we're going to graph each line here, making sure we use the correct type of line, and then we'll decide where to shade. So y is greater than or equal to 2x minus 3. Let's do that. Down 3. Slope is 2, so up 2 over 1. Or down 2, left 1. And because our inequality symbol has the equal to bar on it, we're going to use a solid line. Okay. Now, this symbol says greater than. So we would shade up above this red line. So just to kind of illustrate that, I'm going to highlight this area. So I guess the highlighter here is orange, but you get the idea. Now I'll use a different color for this next line. Y is greater than or equal to negative 1/2 x plus 2. So it starts up here at 2. Negative 1 over 2x, so down 1, right 2. Or up 1, left 2. It also has the equal to bar, so we're going to use a solid line. And it says greater than or equal to, so again it'll be shaded above. And so that will be this region here. Now the actual solution to the system of inequalities is where these two shaded regions overlap, which is in this section right here at the top. So what we'll want to do is actually just kind of shade in. If you were using a pencil, you would kind of shade lightly, but we can just do kind of like this. And I'm going to take out these highlighters just because we know now where the actual solution is. It's right here in the middle. So above this line, those two rules, those two areas overlap right there. And so this is the only region that we shade in. Now to pick any solution, we're just going to pick one of the points in the shaded area. So any point that falls in this region is a solution to the inequality, and including any point on a solid line in that region is part of the solution as well, because remember the solid line is used when it's or equal to, and so these are also solutions of the system. So we can just pick a random point here, say this point right here is fine, so that's 0.23. That works, but there are an infinite number of points in here. Feel free to pick any of them. Next example, we got y is less than negative 1/2 x plus 5, and y is greater than or equal to x plus 2. So the first one, y is less than negative 1/2 x plus 5. So up 5, negative 1/2, so down 1, right 2 for the slope, or up 1 and left 2. Now this does not have the equal to bar on the symbol, so we're going to use a dotted line. Okay, and it is less than, so it is being shaded down. So let's just remember shaded down on that one. Okay, next equation. Greater than or equal to x plus 2. This one starts here at 2. Slope is 1, so up 1 over 1. Or down 1, left 1. It uses a solid line. And it is greater than or equal to, so it is shaded up from that line. So we have to find the region where these two places overlap. So if you kind of imagine the shading, the first line, or the dotted line, would be shaded this way, but the second line, the solid line, is shaded up here. And so the place where those two areas overlap is right here on the left-hand side, right there. So our solution set is this region right here on the left-hand side between those two lines. Now to pick a solution, again, we're just going to pick one point that's shaded in, keeping in mind that any point on the solid line in this area is a solution, but any line on this dotted line, or any point on this dotted line, is not part of the solution, because a dotted line is not or equal to, it is just marking where the solution starts, but it is not included. So let's just pick a point. Let's just say, let's go ahead and pick this one on the line, on that solid line. So negative 1, 1 is a possible solution, but really any point in this area, including this solid line, will work. Okay, next one. Our first inequality is 2y minus 4x is greater than or equal to 6. We're going to have to solve that one. Let's go ahead and do that. We're going to add 4x to both sides. So 2y is greater than or equal to 4x plus 6. Divide everything by 2. And we get y is greater than or equal to 2x plus 3. So we have this one to graph and this one. Let's do that first one. Y is greater than or equal to negative 1/3 x minus 4. Start down 4. The slope is negative 1/3, so down 1, right 3. Or up 1, left 3. And it is a solid line because it has the equal to bar on the symbol. Okay, and it is greater than or equal to, so it's going to be shaded up. Let's just remember that. Now the next line, y is greater than or equal to 2x plus 3. Same symbol, greater than or equal to, but the slope is 2. So we start at 3 and then up 2 over 1. Or down 2, left 1. And it is also a solid line because it has the equal to bar on that symbol. And it is also shaded above. And so you can see where the overlap would be. This line is shaded above, so it's here. And the other line is shaded above, so it's like this. And the overlapping area is right here. This region right there. And so now we just need to pick one point in that area. Again, keeping in mind the points on these lines are okay to use because the lines are solid. Let's just pick, I don't know, this point right here. So negative 2, 2 is a possible solution of that line or that system. Any of those points will work fine. Okay, for example D, the first inequality is ready to graph, so we can go ahead and graph that. Now you'll notice this one doesn't have a y-intercept. There's no number there. And remember, when that happens, you can think of it as having a +0, an invisible +0 there that you don't have to write. So this inequality will start at the origin, right here at 0, 0. And then our slope is 1/2, so up 1 over 2, up 1 over 2, down 1, left 2. Now this line we'll use a solid line because of the equal to bar there. And it says y is greater than or equal to 1/2 x, so it's going to be shaded up here, but we'll save that for the end. So our second equation, we do have to solve for y first. So let's go ahead and subtract 3x, move this x term over to the other side. Now remember, you can't subtract 12 minus 3x. So we just write the two terms next to each other, negative 3x plus 12. And then finally divide by negative 6. So remember, when you divide by a negative, your inequality symbol flips. So we get y is less than or equal to. Then we have this fraction, negative 3 over negative 6. Now those two negatives will cancel out, and 3 over 6 reduces to 1/2. So that is positive 1/2 x. Just leave it like that. And then 12 divided by negative 6, that's a negative 2. So there's our equation, or our inequality rather, in slope-intercept form. Now we can graph it. Starting at negative 2, our slope is 1/2, so up 1 over 2. You'll notice these lines are parallel, which could mean we have a problem. We'll see what happens. We have a solid line here, so I'm going to use that solid line. And it says less than or equal to, so that shades down. Now here's what you have to consider. We're looking for a shaded region where these two inequalities overlap. And in this case, they don't overlap. The red line is shaded above and the blue line is shaded below. So there is no region where these two areas overlap. So there is no solution here. Similar to a system of equations, when your lines are parallel, it is possible to get no solution. However, not every time you have parallel lines in a system of inequalities is it going to be no solution. Because if this red line, for example, had been less than, then it would have been shaded down, and the shaded overlap would be this area here. So you need to be careful. Just look at what the symbols tell you to do, where they tell you to shade. If they don't overlap, it's no solution. But if they do overlap, that's where your solutions are. Y is greater than 3x minus 2, and y is less than 4. So that first one, greater than 3x minus 2, start at negative 2. Going to go up 3 over 1, down 3 left 1. It is a dotted line because it doesn't have the equal to bar. And because it's greater than, we're going to be shading above. So again, somewhere here will be our shaded region over on this side. Sometimes it can help to visualize that after the first line. Just know it's somewhere here, and this zone is going to get cut in half by the next line, and so we can kind of see where to shade in that way. The next line is y is less than 4. It's a horizontal line, again dotted because it doesn't have the equal to bar, so we know it's right here, dotted line through 4 on the y-axis. It is less than, so shaded down below that line. And so we can see that of these choices on the left-hand side, based on the first equation, it was going to be here. We can see that the overlap is just in this section right here. Down from the horizontal line, but up from the diagonal line. And then to pick a point somewhere in here, let's just use this one, 0, 0. The origin is in that region, so why not use it? But remember, these points on the dotted line are not part of the solution, and neither are these points on this dotted line. So they have to be in the region because the lines are dotted. Okay, last example. X is greater than or equal to negative 2, and y is less than negative 1/2 x plus 4. Let's do the x is greater than or equal to negative 2 first. Solid line, because of the equal to bar, and through negative 2 on the x-axis. Remember, these are vertical lines that start with x, so vertical through negative 2. Now it says greater than or equal to. Normally we think of this as up or down, but because x is a vertical line, we can't go up or down, so we have to go left or right, and x gets bigger as you move to the right. So this region right here would be shaded for this inequality. Now this is going to get, again, sliced in half by this next equation, or inequality, so we'll see what happens to it. So y is less than negative 1/2 x plus 4. So start at 4, then we'll go down 1 over 2 for the slope, negative 1/2, or up and left, just like that. We're going to use a dotted line because it doesn't have the equal to bar on the symbol. So dotted line there. And it is shaded down, less than, from that line. So you can see, because we were going to look at this zone here based on the first inequality, the first line, we're narrowing that to just below this diagonal line. So right here is our shaded region for the solution set, and we can pick a point in there. I used 0, 0 last time, so let's just pick maybe this one, 5, negative 2. That's fine, but any point here and on this solid line would be appropriate for that line, for that solution.